Hi viewers, in today's video we will look at CSSP Domain 3. Domain 3 is security architecture and engineering. In this domain we will look at different security models, the architecture, design, virtualization, cloud and solution we use to protect our assets. We also look at how computer works and how they are logically segmented, threats to our application system and devices, cryptography and physical security. So we will start with the security model fundamentals. Security models provide the rules for how we can secure our data while focusing on different goals and what they provide. Following are some of the security models we have. So we'll start with the DAC. DAC stands for Discretionary Access Control. It gives subject full control of objects they have created or have been designed access to. Then we have MAC. MAC stands for Mandatory Access Control. It is system info access control based on a subject's clearance and the object's label. So depending upon the classification level, access control has been granted in MAC. Then we have role-based access control. In this access control, where access to the object is granted based on the role of the subject, like admin, supervisor, and so on. So based on the roles, access has been granted. Then we have a back. A back is something is the access control model which is getting recognition in last couple of years and it is getting accepted very fastly. A back is where a back stands for attribute based access control is where access to subject is granted based on subjects, objects and environmental conditions. Attributes should be subject username, role ID, clearance, etc. Object resource attributes can be name, honor, and date of creation. Environment can be location and or time of access and threat level. For example, the CEO of a company can access data from his own country. If there's a traffic from outside the country, then this is something suspicious. So based on the attribute of environmental, that location of the person, access has been granted. Similarly, there's an office where working hours are 9 to 5, and after 5, nobody is allowed to access the work. So if there's any traffic after the 5, let's say at midnight, then definitely it is suspicious because no one is allowed to access data after 5 p.m. There's another access control, RUBAC, which stands for rule-based access control, and it is access credit based on if then statement. This is normally used in the firewalls. The RUBAC is not a security model like others, but just I'm explaining, so don't confuse RUBAC with RBAC. Okay. After RBAC, there are different models. Like some of them are like Bell LaPadula. Bell LaPadula maintain the confidentiality of the object, so it is also based on the mandatory access control. It has three attributes. First attribute is simple security property, no read up. So subject with secret can't read top secret data. Then we have star security property, no write down. Subjects with top secret clearance can't write top secret information to secret folder. So based on your clearance level, you cannot write something below your clearance level. And the last one property is strong star property, no read or write up and down. Subjects can only access on their own level. So based on your classification, you can access only your level of data. After Bell LaPadula, we have Biba. Biba is used for maintaining the integrity of the object, and it is also the mandatory access control. It also has three attributes just like Bell LaPadula. So first one is simple integrity axiom, no read down. Subject with top secret clearance can't read secret data. So based on your classifier, you cannot read data below your level. So the top secret can't be confused from the data which is below their clearance level. Star integrity axiom, no write up. So lower level cannot write to the database higher than the clearance level. The last one is invocation property, no read or write up. Subject can never access all the data on a high level, so they cannot read or write data below their clearance level. There is also one lattice-based access control (LBAC). This is also mandatory access control. So consider that a subject can have multiple access right. Let's say there is a subject with rights a secret with chemical, so he can access only the attributes related to the data attributes and data related to the chemical. He cannot access data related to secret crypto. Okay, so based on the attribute and the clearance level, the roles are assigned to the subject. Okay. In the real life, definitely there can be many different complex examples. So it can be used in the access matrix format where roles are defined of each and every user. We have also Graham-Denning model uses subject, objects, and rules. So there are 8 rules that specify subject can execute on an object are. So there are 8 rules that subject can execute on subject, and these rules are transfer access, grant access, delete access, read object, create object, destroy object, create subject, destroy subject. We have Harrison-Russo-Ullman model, or HRU. It's an operating system level computer security model that deals with the integrity of access right in the system. It is an extension of Graham-Denning model based around the idea of finite set of procedure being available to edit the access right of a subject on an object. It also considers subject to be objects too, unlike Graham-Denning. So instead of 8 in like in Graham-Denning model, in this model they use 6 primitive operations. These primitive operations are create object, create subject, destroy object, enter write into access matrix, and delete write from the access matrix. We have a Clark-Wilson model. This maintains the integrity of the data. So it separates end user from the backend data through well-formed transaction and separation of duty. So in this one, the subject in this model, rules make sure that there is separation of duty. Consider that in the invoicing or the procurement department, no one person can do all the transactions. Okay. So the model uses subject, program, object. We have this. So in the program makes program make sure that the separation of duty remains there and it doesn't do any conflict of interest. Okay. So consider that like a cashier invoicing procurement department where one person cannot raise the invoice and approve it as well. So there are 2 persons who will be required to do this transaction, and it is to make sure that well-formed transactions are a series of operations that transition the system from one consistent state to another system state. Okay. Another example of this model can be Amazon. In Amazon, a normal user can add to the cart and do the payment. On the back hand, on the back end application detect one item from the inventory depending upon the logic. We have then a Briones model, which is also known as Chinese wall or information barrier. It is designed to provide controls that mitigate the conflict of interest in commercial organization and is built upon information flow model. No information can flow between the subjects and objects in a way that would create a conflict of interest. Then we have non-interference model that ensure that any transaction that take place at a high level security level do not affect or interfere with actions that take place at a lower level. This model is not concerned with data flow, but with the subjects knows about the state of system. Any change by a high level system will never be noticed by low level subjects. So based on the classification level, you can do that modification on your level only, and it will nobody know the level above you and below you will not be able to know about the transactions. Then we have take grant protection model. In this one, it chooses the rules that govern the interaction between the subject and object. It chooses a permission that subject can grant or take from other subjects. It has 4 rules: take, grant, create, and remove. In take, rule allows the subject to take Rights of another objects. Grant rule allows a subject to grant own rights to another objects. Create rule allows a subject to create new objects. Remove rule allows subject to remove rights it has over another object. Okay. Access control matrix. Access control matrix is a normal which we use in our organization that describe the rules of every subject or for every object in the system. An access matrix like Excel sheet is used and one row per subject and a column for the object. So based on the rules, the role of each user has been defined, and following is one of the examples. It is also called a capability list. The column shows access control for each object of the application. That's all for today lecture. Thank you very much.